let's go back to February 1993 on www.talk mailing list.
This man, Mark Andreessen, he's the creator of Mosaic, one of the earliest web browsers. He wrote this: I'd like to propose a new optional HTML tag, image.
And this man replied, Sir Tim Berners-Lee. He wrote, or how about entity, icon 6, system, URL, and icon 6.
And Mark replied, quick, Tim, look over there. And 2 months later, Mosaic shipped with the image tag.
It's really fair to say that image has been pretty popular on the web for the past 25 years, right?
Yes.
In fact, according to HTTP Archive, average web page loads a 650 kilobyte of images. That means it's 52% of page content.
Yeah, and images are less blocking compared to things like CSS and scripts, but they can take bandwidth away from more important things. And of course, if the image is your primary content, loading it quickly is very important.
Yeah, unfortunately, websites throw those bytes away by using really inefficient codec, like the one that comes with Photoshop.
There are better options as well. So this is MozJPEG from Mozilla, but there is also WebP, which is probably supported by the majority of your visitors. As you can see, WebP has beaten MozJPEG, but both of them have done really, really well compared to Photoshop's JPEG encoder.
Yeah, but except you can't really see it, you know? Or you can see some text and numbers, and these command line tools are great for batch processing and automating your build process and everything. But when you are trying to build a site and trying to choose something, it's really not good experience to change the option, because you can't really see the effects of the image while you're doing it. So a lot of innovative small compressions are hidden behind these texts.
Yeah, and it winds me up every time I see a new image format come out, because you get these really bold claims and a few sample images, and I'm left feeling, I don't believe you. I don't believe you unless I can try it in an easy way using my own images, not cherry-picked examples. So we thought, let's make image compression easy using the world's most accessible GUI, the web.
Yeah, so that's what we did. I'm really excited for this slide, because I get to do this announcements of the product thing.
Yeah.
So here we go. Today, we are excited to announce new progressive web app, Scooch.
Yay. OK, fair enough.
Did you like that animation?
It's a beautiful animation. Well done. OK, so now the most terrifying part of any presentation, we are going to give a live demo a go. And with the big web quiz failing earlier, luck isn't on our side. Actually, so with the big web quiz stuff, I had noticed some of the answers changing from underneath me as I was correcting them and editing them yesterday. And when that happened, I kind of thought, well, what could have happened here? Could Surma have coded it wrong? Or am I so jet-lagged I don't really know what's going on? And I went for that one. I just didn't believe Surma could have done it wrong. OK, are you ready to go?
Yep.
OK. It's going to be fine. So OK, this is Scooch. This is Scooch.app. So all we need now is an image to compress. And there are some example ones along the bottom here. But let's pick a real-world example. I'm going to go to the Google I/O website. This is the one from this year. Now, that header image there is a massive 1.7 megabytes, and that is a large portion of the page weight here. So we're going to save that image, and we're going to drag it into Scooch. With Scooch, it supports the file picker. It supports copy and paste. But in this case, we're just going to use a drag and drop. There we go. So on the left-hand side here, we've got the original 1.7 megabyte image, and on the right-hand side, we've got MozJPEG. As you can see, straight away, MozJPEG has taken it from 1.7 megabytes to 500K. That's huge. And to my eyes, I can't really see a difference between the two. If we zoom right in to the folks on the screen here, we can start to see the difference. We drag from side to side. There you go, slight difference. But it's not going to be displayed like this on the website. It's displayed zoomed out, and you can't see a difference. All this is this kind of interface. This works with sort of touch events and stuff as well. You can touch the screen and do it, so it works great on a Chromebook. I was paid to say that, but it is nonetheless true. But because it's displayed for these, it's optimized for high-resolution screens, this big image. Well, we can tweak the settings based on that. So we're going to bring the quality down to 44. Obviously one that we rehearsed. And that's just because it's going to be resized down like that. And we can't really go lower than 44 because it starts picking up banding issues, especially around the sky bit there. But we've really dropped the file size. It's almost another 200K gone. Now, lossy formats, they work by removing data that humans aren't very good at seeing anyway. So for instance, we're more sensitive to changes in brightness than changes in color. So these lossy formats, they'll store color data at a lower resolution than the brightness data. But again, since this is aimed at high-density screens, we can go even lower. So we're going to dive into these advanced settings here. We try to expose everything that these codecs can do. So there's some kind of scary things here, like trellis multipass. What does that do? Well, I have absolutely no idea, but I can check this. I can see the impact of it. It's really cheap for me to try it. I'm not breaking anything.
The great thing about having UI is that you can see it right here, right? And you can figure that out, like toggle it.
Yeah, you can start to learn.
And if it's command line tool, you can't really see until the thing is finished, right?
Absolutely. And one of the options we are going to look at is the auto subsample chroma. This is the thing that's changing the resolution of the color data. By default, it halves it, but we're going to quarter it. And that's like another 20K gone as well. So we've now reduced it by like 83% of the original that is on the I/O website. If we zoom right in, it's looking like a bit of a mess. You can really see the difference there. But again, zoomed out, which is how it's displayed on the site, it's really different. It's really difficult to tell the difference. Mozilla have done an amazing job at getting the most out of an old image format like JPEG, but let's compare it to WebP. So on the left-hand side, we're going to switch to WebP, and we'll drop the quality down to 20. WebP is a much more modern image format. It's based on the VP8 video codec. It's supported in Chrome. It's coming to Edge, Edge 18, Firefox 65. But straight off now, we're going to be sort of round about,
yes.
There we go, about another 100K. Less than the JPEG. Like it's a tenth of the size of the original. If we zoom into those people on the screen again, we can start to see the difference between the two codecs. Like JPEG goes for a sort of very blocky look, whereas WebP loses details through smoothing. In fact, the WebP at this size kind of looks, in some ways, worse than the JPEG. I don't know, it's subjective. But that's also because we've been able to drop the quality of the WebP a lot more, because it doesn't suffer from those banding issues that we get with JPEG. And again, zoomed out, there's barely a difference. So now we've done that, we can download the two images and hopefully send them to the people who run the I/O site, because that's 1.4 megabytes saved for every visitor that supports WebP, 1.3 megabytes saved for people who just support JPEG. So that's lossy compression. But we support lossless compression as well. The Scooch logo here, this is an SVG. Vector formats are great, right? Because they're maximum resolution on any device density, any size. But it's worth looking at how this comes out in a non-vector format. This looks a bit broken. This is because we're using JPEG, which doesn't support transparency. So we'll change to another format. We'll change to OptiPNG, which is an optimized PNG format. Once we do that, it's bigger. It's over twice the size, which is not great. But we can optimize for these kind of codecs. So we're going to reduce the palette. We're going to bring it down to, I don't know, 70 colors. And we can turn off dithering because we're happy with just a flat color there. And once we do that, we are now smaller with the PNG versus the SVG. It's just a few K. If we zoom right in, we can start to see, I don't know, very subtle differences. But zoomed out, it's not a big deal at all. But let's throw this at WebP's lossless mode. So we're going to copy the settings from one side to the other, so we can we keep the reduced palette data, switch to WebP, and put it in lossless mode. So WebP's lossless codec, it's kind of like a completely different codec. They should have probably called it something different, because it's much more similar to PNG. But now you can see we've cut even more off the file size. We're 34% smaller than what we were with the PNG. With the SVG even. But this is yet another cherry-picked demo. We have scripted this to look good on stage, right? What I am saying to you right now is literally written on this screen, including that, and that, and that, and this.
Excuse me? Yeah, well, but all we are saying is that just don't trust our demo. Just go to our app, throw your own image, and try it out, and see how many bytes you can shove off that image by keeping acceptable quality. So we can go back to the slides now.
OK, so That's the good parts. But Scooch is still in beta. It isn't finished yet. There's a few rough edges.
Yeah.
And we do want to be honest about that. For instance, right now, if you open it in Firefox, you get this. We're a little bit behind on our browser support. Come on, we ran out of time. We are hoping to fix this.
Yeah, we had the big web quiz to build.
We had other things to build. We are joking, of course. Come on. Right.
Yeah, as well as being a useful tool, which we hope that you find it useful too, we wanted to practice what we preach. So we wanted to make the Scooch to be a great PWA. So Scooch works in latest version of all modern browsers.
Look.
Well, this is
Only Googlers can get a round of applause for just making things work in the browser.
Yes, this is kind of sad that we got applause for this.
Yes. In fact, like what you're seeing here is Firefox 63 opening a WebP of my stupid cats. And this is in Firefox 63, which does not support WebP. WebP support doesn't land until Firefox 65.
Yeah, but we didn't want the key features to be missing, so we needed to make sure that Scooch could read and create images in all modern browsers using those codecs. Which brings on to, let's talk about how we built Scooch.
Yeah, and this is an idea I had around about 5 years ago. It's something I've been wanting to build, and I tried to build it 5 years ago, but browsers weren't quite smart enough, but more importantly, I wasn't quite smart enough. So Scooch is a real team effort with contributions from all of these talented engineers and Paul Kinlan.
The key thing that made... You got that joke landed really well.
Thank you.
The key thing that made Scooch possible is WebAssembly, which is supported in all modern browsers for over a year now. I know we have WebAssembly sessions later in this conference, but as a little primer, WASM, or WebAssembly, is a compile target for the web. So you have your code written in C, Rust, Go, or whatever choice. You would usually compile it to run it on different OS as an app. But using WebAssembly, the technology, you can compile the same code and run it in browser. So for Scooch, the mods JPEG, the WebP, the OptiPNG, all of those codecs are written in C. So we use the tool called mscripten to compile those C code into a WebAssembly so that we can run it in browser.
Yeah, and this was really, really essential for the projects because browsers do actually ship with image encoders like JPEG and PNG, which you can access via the Canvas API like this. But they suck. They are really, really bad. We have made them available in Scooch, so you can use them if you want. They are actually quite fast. That's the one thing they've got going for them. We thought, why not? But you only get this one quality option, and they're just rubbish. Like this is Chrome's JPEG encoder on the left compared to Moz JPEG, and it's the Chrome version is just a lot rougher. It's horrible. It's actually way worse in Firefox. The JPEG encoder in Mozilla's browser is terrible compared to Mozilla's JPEG encoder.
Yeah, we see the same thing for PNG too. So that Scooch logo that we looked at in the demo, if you use a browser's native compressor, then those are the numbers you get. The Firefox are significantly better than other browsers, but it's still not good compared to OptiPNG, which Scooch uses. And this is for exactly the same image, pixel by pixel, just compression, different numbers.
Exactly. WASM lets us bypass the browser's encoders and use much better ones. It also let us bring in the WebP decoder to use in browsers that don't have native WebP support. Now, I know almost nothing about C, and so that part of the project was really down to this man. So please, welcome to the stage. So good, we named him once. It's Summer!
So,
yeah.
You made most of the WebAssembly stuff work.
Yeah.
How was it?
It was good.
Oh. Cool. Summer, ladies and gentlemen.
Yeah, well, thankfully, Summer wrote an article about it, so we have some things to share.
Yeah, compiling a codec to WASM, that involved writing a little bit of C++, which included the codec and some of the mscripting stuff, and then rewrote a function. This is the function we want to expose to JavaScript. It takes our image data, takes it as a string, because that's how mscripting represents binary data in C++. So on the JavaScript side, we're passing in a uint8 array, and it ends up in C++ as a string. And we also have our other arguments, width and height, and the codec settings. In this example, I'm just using quality. And then we call out to the actual encoder under the hood, passing it all the settings, getting the output, and then we return it. And this val and type memory view stuff, this is annotation to tell mscripting to treat the return value as a uint8 array back in JavaScript land. And then all we need to do is tell mscripting which methods to expose. That's it.
I'm a web developer. You completely lost me. Like, do you get any of this?
No, I don't understand it either, but I copied the patterns from Surma's article, and hey, it just works. It's great. I was able to take those patterns and use them for different kinds of C projects as well, like text compressors and stuff. It's pretty good. Pretty good.
Yeah, so compiling that code with mscript then gives a JavaScript file and WASM binary. So now you can include that script onto your page, which also loads that WASM binary. And once all of the script is ready, you can just call that encoding function as if you're calling JavaScript.
Yeah, using mscripting, it feels a little bit rough and ready, but the docs are really good, and Surma's article is like good enough to get you started.
Yeah, but in this case, we are dealing with large C project here. And those are really CPU intensive. So that brings us to performance, which we were kind of worried about in the beginning of project, because we knew that's going to be a thing that we need to take care.
Yeah, we're halfway through the talk, so we're actually finally starting to get to the point.
Yeah, so we use Preact to orchestrate the DOM and Webpack to bundle it all together.
Yeah, we use Preact because it does what it does in 3K, which is kind of amazing. We also had Jason on the project. That's probably another reason we wouldn't want to upset him.
Yeah.
And we use Webpack because there isn't really anything else that does what Webpack does, certainly not in the way we wanted it done. We wanted kind of a lot of control over it, and it was really only Webpack.
Yeah. So as a result, our app is 400 kilobyte zipped, all in all, everything. So this is well below the median from HTTP archive, which is 1.5 megabytes. So we're quite happy about that.
Yeah, we're winning. We're happy with that. So the vast majority of that size is the codecs and the processors, like the stuff we've brought in from C land. And that's, 300 kilobytes of that stuff. And I'm pretty sure there's some waste and duplication here, but like I said, mscripting's a little bit rough and ready, and code sharing between WASM modules, it doesn't seem all that easy right now. It's something we'll look into. But we were able to limit that damage by lazy loading these using workers.
Yeah, as we've already seen, compressors, it's CPU intensive. So depending on settings, encoding can take 30 seconds to sometimes minutes. And when that thing is happening and occupying CPU, we don't want that UI to be frozen. We want users to be pinch zooming and moving around and testing and possibly changing the options too. Yeah,
workers give us this lazy loading stuff for free, which is great. But the main benefit is concurrency. We create up to 2 workers, and both of those are just going to be pointing at the same script. That's one for the left-hand side of the image and one for the right-hand side of the image. This means the left-hand side can be encoding a JPEG, and the right-hand side can be optimizing PNG, and all the while the main thread stays responsive. And that was really all the concurrency that we needed.
Yep. But it came with another benefit, too. So the left-hand side, let's say benefit left-hand side worker is compressing an image, right? But what if user changed the setting? The current job is out of date. We need to update it. But those compression encoders are written in synchronous way, so there's no abort API. There's no way to kill it. However, we put it into worker. So in this case, we just terminate the worker, and then create new workers, put the new job in, and then start it back up again.
Yeah, and the implementation for this is pretty simple. So it's just like this. Go on, you click. This is the problem, right? We've got 2 slide clickers, and we needed to rehearse who was doing the changing for each slide. So what you saw there was us messing it up. OK. Implementation is roughly like this. If busy, terminate and restart. But also, we only spin up one of these workers when we need it, just in time. So if you're doing something kind of like what we were doing in the demo, we had the original image on one side, JPEG on the other. We only spin up one worker because we're only having one side doing compression at the time. And also, if one of those workers is idle for 10 seconds, we kill it as well. And that's really just to be kind to the user's device to bring the memory footprint down.
Yeah. The worker is almost empty when it started. Heavy stuff is imported when it's needed. This keeps the worker startup time down. And also, you don't really need to download and parse and wait for the optpng and mod.jpg stuff if user is just encoding WebP.
Yeah, and using like a way to import like this is part of the platform. It's supported behind a flag in Chrome, but it isn't supported in Stable or in other browsers. Thankfully, it's something that Webpack can just handle. It sort of polyfills it, and it just works. Now, the final piece of this puzzle is how we actually talk to the workers.
Yeah, so request and response communication with worker is a little tricky. So the way worker works is that you send the worker some job, and at some point, they come back with the results. But you need to associate those requests and response. So in this code example, we just give a unique ID. And when worker is done with that job, then it gives back the ID. But like you have to write your own logic for this. And it's like,
It's rubbish. I really don't like it. It's one of the things that puts me off putting stuff into the other thread. You know, it's like, oh, I'm going to have to do the post message thing.
Yeah, another layer to worry about, right?
Yeah. But again, to the rescue, it's he built Comlink, a little library that you can get from npm to use it. It's just like this. You create a worker as you usually would, and then you tell Comlink all of the things that you want to expose. These can be classes, values, but we were just using functions. And then over in your page, you just kind of hook the Comlink up to the worker, and now you can call those functions just as if they're part of your page. Comlink takes care of all of the bookkeeping, the post message stuff, all of that mess.
Mm-hmm. So once we've split out that codecs, our app came down to 35 kilobyte.
No.
Yeah, but I want to make sure that user will still have to download those 300 kilobytes if they want to use all of the codecs, but they don't need to load those up front. But 35 kilobyte, it still contains this pinch zoom logic, the options panel, the fancy slider, this thing, that thing, this thing, oh, that thing too. And what these have in common is that it's not here, our first page.
Yeah, imagine going to a restaurant and asking to see the menu, and 10 minutes later, you still haven't been given it. So you go and ask, like, excuse me, where's the menu? And they say, oh, well, we're busy preparing every single dish we do, and then we'll give you the menu. So when you pick something, bam, we will give you that straight away. It's ready.
Yeah, you laugh, but much of the web is built this way, especially JavaScript-heavy apps.
Yeah, because you might look at the menu and decide, oh, I don't want any of this stuff. Or you might want something simple. You're certainly unlikely to want everything. So why should getting the menu and making a choice be blocked on them preparing all of their most complex, time-consuming dishes?
Yeah, same for JavaScript app. They prepare everything up front before doing anything. So the user really shouldn't have to wait for all of these things to download, parse, and execute. They just need to get to this page.
And like most web apps, Scooch has a limited set of first interactions. For us, it's dropping an image onto the page, selecting one via the file picker, or selecting one of the demo images. So we split all of that out. This is roughly how things looked at the start. We had our intro, and we had our compression UI. If no file had been selected, we show the intro. Otherwise, we send that file to the compression UI and display that. We changed this so the whole compression API part, that was loaded asynchronously. And the toolchain actually made that a lot easier than I expected.
Yeah. So first up, we removed the regular import, and instead dynamically imported that in the constructor and set that as a state. So dynamic imports are supported natively in Chrome and Safari, but using Webpack provides similar functionality to all of the browsers.
Yeah, so the compression UI is going to start downloading as soon as the intro loads. But there is a small chance that the user is going to be able to select a file before it's ready, so in which case, we just show a spinner. Very unlikely that the user is going to see that, but we put that in just in case.
Yeah, so remember, with codec, split it out. We shoved that 300 kilobyte off. But with the code splitting, we made that into 15 kilobyte. And this is despite our app being JavaScript-driven, using frameworks. And 15 kilobyte gzipped is even with empty cache on the user's device.
Exactly. And that means on a slow 3G connection, The user gets the first interaction in 3.3 seconds. And that's a slow connection on a slow phone, but it's not the worst conditions. Even on 2G, we are still interactive in less than 5 seconds. Now, I don't think many people in this room spend a lot of time on 2G. I know I don't. But this kind of performance means the app is really usable even in emerging markets. And this is why I'm a huge fan of these micro frameworks like Preact, but also lit-HTML, hyper-HTML, Svelte. We couldn't have actually hit these numbers with React, because that's 30, 40 kilobytes out the door. We couldn't do it with Vue, because that's 20 kilobytes. Angular is 60, Ember is bigger still. But let's not get carried away. 15 kilobytes, 8 of which is JavaScript, is actually a lot of JavaScript for these couple of interactions.
Yeah. So for instance, let's look at how we might build this user interface with just vanilla JavaScript, right? So here's a minimal implementation of drag and drop, just a few lines. And then add that to that drag and drop is the selecting a file code. That's not that much. And then this is for selecting one of the demos, clicking and loading the image. So all of that code, minified and gzipped, it's only 550 bytes.
Or 350 bytes.
Oh.
Whatever. I'll go with the number on the screen.
Can't see the number. Yes, 350 bytes.
And that's why I get really, really grumpy when I see sites with this 600K or more JavaScript bundle, and that's for first interaction. I have friends who build native apps, and when they talk about their 2 megabyte Android instant apps, I love being able to go, instant, 2 megabytes, great, 15K. But then
with your smug face on.
Yeah. I think it's called a shit-eating grin. Anyway, but then they can point to large parts of the web that have thrown this advantage away. Parts of the web that have taken on the worst of native, but none of the benefits.
Yeah, so if you take anything out of this talk, please, please, please study your website or your web apps and find out what the first interaction is and ship the reasonable amount of code for that first interaction. Now, reasonable amount of code, how do we find out? We have a lot of tools.
Yep.
Yeah, just experiment and find out what is reasonable to you.
So you also need to keep an eye on the bundles between builds. And with Webpack, right now, that unfortunately means going and looking at minified code, because that's where it does things like tree shaking and dead code removal. It's part of the minification process.
Yeah, we've run into a few bugs because of that, right?
Yeah, we're still not quite sure if it was a bug in Webpack or if it was our expectations were different to what Webpack was doing. But it was when we dived into the minified bundle, that's when we found that stuff out. Alternatives like Rollup are much better here. They will show you the dead code removal during development, so it's easier to see when something's not going as you expect. But Rollup doesn't have the kind of holistic asset graph that we really needed for this project. Anyway, my point is there are huge gains to be had by keeping an eye on this stuff.
Yeah, so like we said, we use Preact to orchestrate the DOM, but we also use web components. When we were building this system, we were talking to a lot of developers of yeah, we are building this cool app, and you're using Preact, and you're going to be a web component, and they were kind of surprised because they were asking questions like, wait, is it web components alternative to frameworks?
Yeah, but they're not. I don't know why you would think that. Well, actually, I do know why you would think that, and I think it's our fault. Well, I think it's Google's fault. I think our messaging suggested that web components are the same thing as Polymer, and Polymer is an alternative to the frameworks. But web components, they're not the same thing. Web components are the lower-level primitive that Polymer uses.
Yeah, we did use Polymer's custom element polyfill for Edge. But for other browsers, we just ship the vanilla web components.
Yeah, we use custom elements of some of our Leaf components that contained a minimal amount of state. For instance, this is the pinch zoom element. Just put stuff inside it. Now you can pinch zoom it. And it has an API. We also did this with our side-by-side slidey thing comparison.
We call it 2-up.
We call it a 2-up, yeah, because we didn't know what else to call it. A fancy range input, drop target. We made components for all these bits and pieces.
Yeah, so we could have done all of this in Preact component because we were using Preact. But using web components, we can take that and put it into some other project using different frameworks, or just use it as is in the project that you don't really need framework.
Yeah, and if you're open source inclined, web components are the best way to share things like this. So we did. We have released a few of our web components as separate projects, so we'll make more available as we extract them from the main app. We were hoping to release more, but ran out of time, whatever. We use Preact, but these things, they can be used in Vue, Svelte, Angular, React, whatever.
Yeah, most frameworks are fine with custom web components, but some have few rough edges. So if you're curious, check out customelementseverywhere.com to see how custom elements work with whatever the framework you are using.
We also released libraries for some of the other things we built, like a pointer event helper thing and a Webpack plugin for dealing with asset inlining and optimization. So it has been, well, we're vastly running out of time, 20-odd minutes, and I haven't yet mentioned service workers.
A new record at the very end,
New personal record.
Yeah.
Yes, the site does work offline. Our service worker approach isn't particularly novel. We cache the things, we serve the things. That means it works offline. We also let the user know when there's an update available.
Yeah, but there's one unique thing about this Scooch. That is, when user first visits this site, we cache all of it and the next interaction. But we do not cache any of the codec, the 300 kilobyte bit, until the user access will drop the image and then get to this view.
Yeah, and this is just being kind to the user's bandwidth. Like when the user just visits the site, it feels rude to download the whole 400K app. So we wait for some signal from the user that they're actually interested, and that's when we cache the chunkier parts.
Yeah, and this is what we love about the web, right? Yeah. Write it once, build it, and then put it into phone, tablet, desktop with fraction of the size. Yeah?
Yeah, of the equivalent native app, yeah.
Yeah.
And those native apps are only targeting like one operating system, whereas we can hit loads of them. And to share it, just copy the URL and send it.
That's the best part. That's the best part of the web. Yeah.
Love it.
So if you want to dig into the code, it's all on GitHub. There are lots of things we want to do. There's bugs to fix, codecs we want to include, and if you're interested, please come join us to build this up. We really want this tool to be really useful to everyone.
Yes, absolutely. So thanks for listening. Now go squish some images.
Please never say that again. Thank you very much.
Thank you very much.